Hello, everybody. My name is David Barroso. I'm a network engineer at Spotify, and I'm here to talk about Napalm and how we use it to automate the network. I'm going first to introduce a bit Napalm, and then I'm going to actually do a live demo. So what is Napalm? Napalm is a Python library. It's open source. And the goal of Napalm is to unify as many vendors as we can to provide a single interface to operate them, like to apply config changes to get objects from the device. We support today a few vendors, Arista iOS. We support as well Juniper. We support iOS XR. We support as well FortiOS. And there are a few other coming soon, I hope, by some definition of soon. NXOS, Lenovo OS, Dell FTOS. I don't know where they will be ready, but people is actually working on them. We support different methods for config manipulation. If you are familiar with Junos, you will see that they are kind of familiar. We can replace configuration. We can merge configuration. We can get a diff of the running configuration and the candidate configuration. We can as well discard the candidate configuration if we want. We can commit the changes, or we can roll back the last change. This is the same interface for all the vendors. So it doesn't really matter if it's iOS XR, Arista, Juniper, or FortiOS, or any other vendor that might come in the future. They will support exactly these methods in this way. And we support a few other methods to get objects from the device. We can get some facts, like the device model, the serial number. We can get as well interfaces, and we can get as well the LLDP neighbors. And we also provide a few of Ansible models to be able to use this library, which I will be using in the demo in a few minutes. So now we are going to jump onto the demo. I guess that everybody is familiar with Ansible. Who is using Ansible today? Oh, that's sad. 3 people. I guess that people more or less is familiar with it, even though you're not using it. For those that are not familiar with Ansible, it's a config management system similar to Puppet, Chef, Salt. So if some of them rings a bell, Ansible is yet another one. What we are going to do in the demo is we are going to deploy this network. It's a really simple network. It's not supposed to be like a production network, because it's not, and it wouldn't work probably. But it's just to prove a point. We have 2 P routers. One is running EOS, another one is running iOS XR. Then we have 2 P routers that both are running Junos. But at the end of the demo, I'm going to be replacing one of the P routers running Junos with another one running EOS. And we will do that in a seamless way without having to do any change anywhere, just replacing the hardware. And there are a few customers that they don't really exist, but you will see how you can deploy customers really fast and without really caring about the P router itself. The network topology is going to be self-discovered with LLDP, meaning that I'm not going to care about the links between the P routers and the P routers. LLDP is going to take care of that. The P router will see, like, yeah, I'm connected in this port to the P router in Stockholm. So I have to choose for this port this IP. And everything will be done automatically. Let's walk through Ansible itself. This is how I'm going to define the roles. A role is going to be a service. For example, we have here the P routers and the P routers. The P router is going to have 2 roles, the base conf and the core roles. The base conf is going to define just things that all the devices have to have, like, for example, SNMP, login, users, management, just normal configuration that is more or less common to all the devices. The core is who is going to say, like, yeah, I'm a P router, and I have to configure my links in this way so the P routers can connect with me. And similar to the P router is going to have 3 roles instead, the base conf as well as the P router. And then the upstream is the one that is going to do the magic. The upstream is going to use LLDP to see like, yeah, here, I'm connected in this port to this particular P router. So I have to choose this IP to configure the interface. It's going to configure as well a BGP session, because we are using BGP in the network to communicate everything. And the downstream service is finally the one that is going to deploy the config for connecting to the customers. Every service is templated for every vendor. The service, you can see here, for example, on the left-hand side, you have the downstream service for EOS, and in the right-hand side is just exactly the same, but for Junos. Both are going to have exactly the same input. I mean, I'm going to use exactly the same variables, and they are going to produce the same outcome. In this particular case, it's just configure the port connecting to the customer and configuring the BGP session and assigning the right policy for that particular customer. That will allow us to deploy services without really caring about the vendor when we are actually operating the network. So this is a one-off. When you, I mean, a one-shot only. When you define your services, you do it, and after that, you don't have to care anymore. This is the data that we are going to use to deploy the network. You can see, for example, that we have a user, we have our DNS server, we have our NTP servers, we have the core interconnects. This is the prefixes that the core and the upstream services are going to use to configure the network. For example, if any P router is connecting to the P router in London, it's going to use this particular prefix. So there are some maths internally in the templates, so they can figure out which exact /31 to use. But that's really easy. And then finally, just the AS numbers. The core is going to have 65,000 everywhere. I mean, both of them. And then Stockholm is going to have 65,100, and the other one 65,101. And this is the only data that we need in the P routers. You can see that the data is in both cases the same. So we don't really have to care about the vendor. You can see the first variable, it's telling the system which operating system that device is running. So the first one is Junos, and the second one is EOS. But after that, everything is same data. You need a management IP. You need to define a downstream network range. This is the network that you will use to connect to the customers. And then finally, the customers. You need a name, you need a port, you need an AS number, and you need a policy. So it's completely vendor agnostic. Same data, no matter which vendor you're working with. And the same for the plays. Plays are how an action is declared in Ansible. This is the play to actually retrieve the facts from the device. The facts is going to retrieve things like the serial number of the device, like the interfaces available, the hardware model, well, several other stuff. In this particular case, I tweaked the get facts as well to get LLDP information, because I will be using that information for the core and the upstream services. Once we run Ansible, we are going to do a few things. The first thing we are going to do is we are going to get the configuration for all the services, or we are going to compile it in one running config. Well, not running, in a candidate config. That candidate config, we are going to send it to the device, and we are going to ask the device to send us a diff. For example, this would be the full configuration for one of the devices. Not sure which one, but it doesn't really matter. And on the right-hand side, you can see that I got a diff. Like there was a running config on the device, and I got a diff to the candidate config. So I can see exactly what changes I'm going to apply, so I can validate them if I want, or I can just log them. So if something goes wrong or there is an outage, I can actually go there and see, like, yeah, well, what was the actual change? So let's go. We are going to deploy the network. We are going to deploy the downstream services, meaning that we are going to connect to a few users, although the customers, they don't really exist, so we will see that everything is configured, but the BGP session will never come up. Then we are going to replace one of the P routers with another vendor. We'll take down the switch, we will add another switch with a different operating system, and we'll just deploy it with one command without caring about anything. I'm going to show that changes are idempotent, meaning that either the changes go all of them through or no change will go through. Like if there is an error or whatever, nothing will go through. You won't be on a state where you don't know what's your state because you applied only half of the configuration. And I'm going to show as well that that changes are only applied if needed. If there is no change to apply, then we don't do anything. And that will be handled automatically by the system. So let's go. Is it big? Can you see it, everybody? Perfect. So first, let's walk through the devices. This is the P router. I'm going to show that there is no config. It's completely empty. I only have configured the management and the netconf interface. This is IOS XR. I guess everybody knows this. And this is EOS, Arista, the same. Only the management VRF is configured and the API. Nothing else, config is empty, and the same for the P routers, which were Junos. Everything is just management. Only management is configured. So we are going to run now Ansible. Ansible is going to be run in two stages. The first stage is going to compile the full configuration of the device. The new one that we want is going to send it to the device and ask back a diff. Then we are going to review the diff, and if we are happy with it, we will run Ansible again saying, now apply the changes. And in that second stage, there will be no new compiling of the configuration. Just the previous config that was compiled, it will just be pushed to the devices. So Ansible play configure network host. And this is actually who is going to say that don't apply any changes, just give me back the diff. So first of all, it's going to be removing some old stuff to make sure that we don't make any mistake by applying anything that was previously there. Now it's getting the facts from the device, connecting to the device and say, like, can you give me your LDP neighbors? Can you tell me which interface that you have available, your serial number, your product number? And now it's actually doing building the config for the P routers, the base conf, the core service. Then it went to the P routers, base conf upstream, downstream, and it finally compiled the configuration in this step and pushed the configuration to the device. But we didn't apply anything yet. We just wanted to have the diff. And we can see here that the Ansible detected that there was some changes in devices. So we can go there and we can say, like, let's see, I don't know, the P0, for example, in London. We can see here that we have different services. This would be like the baseconf role. You can see that we are using this role to deploy like the host name, the management VRF, NTP, to enable LDP, well, just management-related stuff. It's not that interesting. And we can see that we are using the core service to configure the interfaces and the neighbors. You can see here that it detected with LLDP that is connecting in some port with this P router, in this port to the same P router. There is a P router that had two links connecting to this particular P router, in case you didn't notice. And finally, you can see that what we did is just combine all the files and create the entire running config. And finally, as I mentioned, we can see the diff. We are adding stuff. We are not deleting anything. And the same if we go to the other ones. This is the EOS. And here you can see that we are doing similar thing. We are adding NTP. We are configuring neighbors. It's a completely different operating system, but once you have built the templates, you don't care. You just run Ansible, and Ansible will take care of everything. We could go to one of the P routers as well. And the same here, but just Junos style. You can see that the interfaces are configured, the BGP neighbors. And now we are going to deploy it. We go, it's the same command as before, but now we say commit changes. All the configuration steps are going to be skipped. Like, we already compiled the config before, so we don't want to recreate the config. We just want to apply it. So if everything goes fine, we will have the config deployed. Now, the P routers have been configured, and now we are going to the P routers. Junos is a bit slower applying config. It has a lot of internal checks. Let's hope it works. I can feel the tension here. Yeah, everything is virtual, so it's kind of slow. I mean, it's a virtual lab. Well, it went through. We didn't break anything. That's good. So now the changes should be there. We can go to the devices and actually check everyone. Show run. Yeah, we have a lot of stuff that we didn't have before. Right. Everything seems fine. Nice. So let's see that we have too many BGP. Some. We have the connections going to the P routers up and running, and we don't have the downstreams up and running because they don't really exist. But for once, we were faster than the customers deploying the links. And we can do the same here. You can see that. Why do we have so many CLIs? Here. This one had 2 connections, only one to each one, to each P router, and this had this is IPv4 BGP summary. No. Here. And everything is up and running. Something we are going to do now is we are going to replace one of the P routers. Everything is virtual, so what I'm going to do is actually we are going to go here. We are going to delete the interfaces. GE0. No, not that one. What we are doing now is replacing this P00.stow with another device that will be running EOS instead. The lab is virtual, so to kind of simulate that, I will just break the connectivity. And bring up the connectivity to the new device. Now, okay. So this one shouldn't have any LLDP neighbor now. Perfect. Only that's the management interface. Exit. And now we have this one. Which is running EOS. You can see that it only has the management configuration so far, and I had the interfaces shut down, so LLDP wouldn't go nuts. Okay, no shot. So now we should get LLDP information soon. Come on. this was supposed to have, let's go to the, yeah, this was supposed to have another link. Why it's not up? Ah, now, sorry for that. So if we go to the P routers, we should have the same inform. Yeah, let's clear LDP and neighbors, no, table. Yeah, let's clear this, so make sure that we don't have any. How do you clear this table? I mean, we are using LDP to auto discover the network, so we have to make sure that the data is correct, that we don't have still the previous LLDP information. Well, while this is populated, I can show you how we are going to do the actual change. Now we are going to edit the host file. The host file is where you define which devices you have. So we are going to disable the old P router, and we are going to enable the new one. And then we are going to see the variables. This is the file that I showed before in the slides. This is the PE00. This was the old one. And now we have a new one that I already created. But you can see that it's exactly the same. The only difference is the operating system, which is EOS, and the management IP. That's the only differences. The rest is just the same. Same downstream network and same downstream information for connecting to the customers. So if this is finally, yeah, this is fine now. Well, now we are ready to go. So now we go to this. We are going to build the new configuration. I mean, if this was a physical lab, you should replace all the LLDP clearing and everything with, and shutting down interfaces with actually calling the data center rack and rack. So now we are building the configuration again for all the devices. And the first thing now is it should detect that some devices are going to change and some others are not. Perfect. For example, the P router in London, nothing changed there. So it's just saying like, yeah, this is okay. We don't have to do anything here. But the rest of the devices, there was some tiny changes. So let's go and see them. For example, the P router in London. What has actually changed? Oh, sorry. And the only thing that has actually changed is the description. Now LLDP has detected that it's connected to a new device, so it just updated that. And if we go to the one in Stockholm, we should have exactly the same change. And just the description change. I mean, we are connecting the old device to the new device to where the old one was connected, so there is actually no change. I mean, same IP, same neighbor, it's just changing the host name. And if we go to the P install, we can see that we are configuring the upstream routers, the downstream routers. Well, everything seems fine, so let's just apply the changes. We skip all the compiling configuration steps, and we go straight to committing them. Okay, everything went through. You can see that now this went super fast instead of spending like 90 seconds on it. That was because there was no changes, so there was nothing actually to calculate inside the box. It was just ignore that step. So let's go here again, and let's see. MP4 BGP summary. I hate this. Everything is up and running. you can see that with no effort at all, we just replaced a device with a complete different vendor. Who has tried to do this before? How easy it was? And this is even worse if you are dealing with a firewall. And now we are going to prove that changes are only applied if all the changes are correct. We are going to, let's say that we are going to, some operator is fat fingering somehow. Let's go to the host bars, for example. And let's use the new one that we deployed. Some operator is kind of fiddling with the downstreams, and somehow it, I don't know, this is not a valid AS number. So let's introduce this typo and see what happens. We are going to compile the config and see what happens here. We compile the configuration. Now we are going to see what the device has to tell this new configuration. That was interesting. Oh, right. That's yeah, I forgot that now you can have AS numbers as big as this one. Let's just introduce a character. Yeah, I forgot about 4 bytes ASN. And now we can see that the device actually said, like, hey, no way. I mean, this line here is not correct, so there is something wrong. So the device is not even going to try anything. Like, you have something wrong on your config. And this is important. I mean, we are so used to just copy-pasting config and realizing during the pasting phase that some commands didn't went through, and like, oh, wow, what is going to happen when this finishes? And you might even log you out. And this is it for the demo. And what we've seen is how we are using at Spotify, more or less. I mean, this is not our network, and this is not exactly our workflow, but it's kind of similar. But you can see that we break down devices into different services, and then we template those services for every vendor that we have. At the end, what we do is just compile the full configuration, push it to the device, get the diff back, and say, yeah, I'm happy with it, so just commit the changes. And the interesting thing is that when you start doing this workflow, your network becomes completely vendor agnostic. You don't care what device you are buying for your network. You can go to Juniper and say, like, yeah, Arista is giving me this price. And you lower it. Yeah, sure. Then you go back to Arista, like, yeah, Juniper is giving me this other price. And yeah, your finance people will be happy with that. And this is it. As I mentioned, it's an open source tool, so it's available on GitHub. There is a mailing list, so feel free to join if you want to play with it. The code for the demo is available on GitHub as well. So you can go to that link as well and just see the templates and everything. They are not supposed to be production ready, but at least you can see how I did what I just showed you. And just drop me an email if you have any other question. Elisa was working originally in this tool with me. Now there is a lot of other people as well, but just drop us an email or go to the mailing list. And you have any question right now, or you want to see something in particular about the demo, just feel free. It was a yes somewhere.
Hello? Yeah, okay. We got an exception there before when you changed the AES number to being an invalid one. So is this something that, I mean, you kind of mentioned that you load the configuration on the box and that's what gives you the diff.
Yeah.
So are you relying on that you have some form of candidate configuration or something on the device, or how do you deal with this on a device that doesn't support that?
I mean, all the devices that I was using in this demo has that particular feature. If they don't have it, because you are using a vendor that you shouldn't be using, probably, then it's up to the backend library that we use to solve it. For example, I mentioned that FortiOS was supported. Then you will see the error not during the compiling of the configuration, but during the actual commit. But it will roll back the changes because FortiOS doesn't support atomic operations. So we use some tricks that the box supports. For example, you can, on FortiOS, they call it execute batch. And that allows you to send a full list of commands, throw them all, and then afterwards get back the result of them. So you can see actually if some command went failed and why it failed. So with FortiOS, for example, we use that feature to kind of emulate the atomicity of the library. But it's not really atomic. And you will get the error not during the compiling phase, but during the committing phase. So everything is documented. So if you go to the GitHub page, you will see which ones support this feature nicely and which don't. And I would suggest you to choose the right vendor. And don't use like iOS, for example.
Great. So, okay, next question would be, can you reverse the changes that you have applied?
Yeah, with FortiOS, it's supported. It's automatically done. As I mentioned, the execute batch, for example, you throw all the commands, and then there is another command that will send you back a list of commands that failed and why it failed. So the backend library...
Okay, I'm not talking about, if something fails. I'm talking about, you apply, I don't know, whatever. You have a customer configuration. In 1 year, the customer cancels their service, and you want to back out that particular part. So but between now when you've installed the customer and in a year, you've applied a lot of other things. So you can't just back up like one transaction or something like this.
You mean like back in time, like a year? Not sure if I got the question.
So let's say you install a customer today, and then you're doing a lot of other changes on the box. And all these changes, you want to keep them, but then you want to delete the customer configuration. And you can't just back because all the other stuff that you've done you want to keep that. So can you do do you have an understanding kind of how to do the inverse of applying a configuration?
I mean, if you want to delete, let's say that we want to delete a customer. I mean, let's say that this is not a customer anymore. I mean, you just remove it from here and run Ansible again. Now that customer is gone.
Is generating the full configuration and replacing the entire configuration of the box pretty much.
You're not really rolling back configuration. You're just deploying new configuration, and this new configuration doesn't include this old customer because it's not a customer anymore.
If someone really change something in between, you'll just overwrite all of this, right?
Yeah.
Okay.
Yeah, we always want to deploy full new configuration because we don't want lingering configuration in the device. I can actually show that. Let's actually do it. I'm going to go to a P router, for example, this one, and I'm going to create a VLAN. Let's say that an operator is brave enough to go to the device, name, whatever. And now we have this VLAN here. And I can actually run Ansible now. And because we always deploy full configurations, we don't do rollbacks or partial configs. But this is our workflow. I mean, you could actually do merge configuration instead of just replacing the full config. But in this particular workflow, manual changes are not allowed. You cannot go to a device and change something. So now we will see that Napalm detected that change. Well, Napalm plus Ansible detected that change. And it will actually take it away. Oh, I forgot to fix that typo before. wasn't the one. But yeah, but bottom line is that removing a customer is not actually a rollback. It's just it's moving forward in your business.
Right. Yeah, I understand. Okay. So last question. Netconf Yang.
We are using what is available for every vendor. We are using, for example, with iOS 6R, we are using a combination of SSH plus Netconf, because that's what's available in most platforms. I think that the latest release supports actually a Netconf Yang interface, but that's the very latest. So we went to the one that people could actually use, because we know that usually service providers upgrade the boxes once every 10 years. For Juniper, we are using Netconf. For Arista, we are using the API, and so on and so forth. I mean, we use whatever. That's actually to the backend, to the backend library to fix it. We don't really, and we can see the diff here. We can see that Ansible is trying to remove the VLAN, because that was a change that shouldn't be there. It's not defined in any service.
Thank you.
All right. Good stuff. How do I take my existing configuration in a network and backport it into this? And this is a common problem for anybody building automation tools. We don't start with an empty box, which is very nice, by the way. And sitting and writing the Yang for an existing network is actually quite a task. Can you talk a little bit about the sort of bootstrapping mechanisms that could work here? And I am talking about service provider complex type environments.
Yeah, I mean, we had that problem at Spotify like a year and a half ago, because, I mean, we had a network already up and running. And the approach that we followed was we created a really simple service that was kind of, I don't remember the name, but kind of like static config. And then what we did is dump the existing configuration of the devices in that one. So each one had a tailored static config. And that static config originally was the full running config of the device. And then what we did was just go through the configuration of the devices and start moving that static config to actually dynamic services. For example, you have a file with the config of all of the devices, and then you take the SNMP configuration. You move the SNMP configuration to the base conf. And then the next step, you move now the login configuration, then NTP. Then you start by moving pieces. You start small. You can have, I mean, one of the templates could be just your previous config, and then start moving blocks of config to an actual service. Does that answer your question? It's a lot of work, especially you have a lot of services. But for us, it worked really well. I mean, it was a lot of work. I mean, I'm not going to lie. But now, I mean, we deploy a full new data center in a matter of just a few clicks.
Thank you.
Did you ever have a problem on, we'll say, order of push? For example, if you have a /32 with two hosts and one is at the end, and you change the point-to-point, you will lose connectivity. Did you ever encounter a problem where, I will say, the fact that the hosts are pushing an order caused you issue?
Not sure if I understood the question.
When you're pushing your change, they are done, every router is changed one after the other in a sequential manner. So did you ever encounter in production problem where the sequence of push did cause you issue?
Yeah. Yeah, I see what you mean. We mostly run, well, we usually have like several links. Like for example, we don't operate a service provider network at Spotify. We have a data center. And then you usually have this kind of leaf and spine topology where you have several spines and each leaf connecting to all of them. So if we were going to renumber the spine, for example, let's say that we want to renumber all the links, what we would do is go spine by spine. So then you lose connectivity to one spine, but you still have the other two. When you're happy with that, then you change the next spine. I mean, in this particular example, we could go for example, let's go here. Let's say that we want to renumber the networks that you assign to the P routers. I mean, you could go here and just renumber this one. You run Ansible, you still have the other path, right? So you renumber that one, you're happy with it, then you renumber the other one. So you have to kind of plan your incremental steps so you don't have an outage.
Any other questions for David? Okay, well, thank you very much for your presentation.
Welcome.